So hello everyone, welcome to my database management system series. In this video, I'm going to talk about the scenarios of using a database and traditional file processing methods. So I'm going to talk about the scenarios where a DBMS is considered good, and also the scenarios in which it's a better idea to use traditional file processing, and I'm also going to talk about performance consideration. So now where should we use the database? So scenario 1 is multi-user banking system. So consider a commercial banking application that serves thousands of customers from many branches. In this scenario, hundreds of tellers, ATMs and online banking customers require simultaneous access to account information. Customers can deposit money at one branch while withdrawing from another, check their accounts online and receive transfers all at the same time. So a DBMS is required here because it provides ACID transaction features which ensure that when you transfer money from account A to account B, either both the debit and credit occur or neither happens, preventing money from being lost or duplicated. The DBMS supports concurrent access using advanced locking techniques which ensure that if two tellers access the same account at the same time, the transactions are appropriately serialized. Furthermore, the complicated relationships between clients, accounts, loans, transactions, and branches necessitate the relational model that DBMS provides. Security is critical. So different bank employees require different access levels, which DBMS role-based access control accomplishes flawlessly. So traditional file processing cannot safely handle this level of complexity, parallelism and security. So now let's talk about the next scenario. The next scenario is hospital information management system. So let's consider a major hospital that oversees patient records, appointments, medical histories, billing, pharmacy, inventory and test findings. This system involves departmental integration. When a doctor prescribes medication, the pharmacy must see it, billing must charge for it, and the patient's medical record must be updated. DBMS excels in this context because data integrity is essential. For instance, a patient's blood type or allergy information must be consistent across all departments. Any misstep could have fatal consequences. The DBMS enforces referential integrity, guaranteeing that each prescription refers to a genuine patient and drug. The system requires complicated queries such as for example, find all diabetic patients over 60 which has surgery in the last month and are taking specific medications, which SQL performs beautifully but would necessitate substantial programming in file-based systems. So now let's talk about the scenario in which file processing is better. So the number one is standalone scientific data logger. So consider a distant weather monitoring station that records temperature, humidity and wind speed every minute and stores them consecutively in a file. This is a single-user, single-purpose application with a straightforward data structure. So traditional file processing is excellent in this case since the application's access patterns are totally predictable. It only appends new reads sequentially. There is no need for complicated queries, linkages, or simultaneous access. The simplicity of recording readings in a flat file is both adequate and efficient. Installing and maintaining a database management system would be overkill. It would consume additional resources, require more electricity, which is crucial in distant places, of course that is, and add complexity without benefit. So the sequential file organization corresponds to how the data is collected and handled subsequently. Normally scientists download the full file on a regular basis for examination. A basic lightweight file-based solution is more dependable, easier to maintain and performs better in this particular use case. So the next one is configuration files for embedded systems. So consider a smart thermostat or automobile engine control unit that maintains configuration parameters such as temperature thresholds, user preferences, and calibration values. This data is modest, straightforward, and rarely changes. File processing is more appropriate because the data requirements are modest and have a completely static structure. The gadget has little memory and processing power, thus running a DBMS would be wasteful and unworkable. Access patterns are relatively simple. Read configuration at startup and occasionally edit a setting. So concurrent access, complicated queries, and data element interactions are unnecessary. A basic configuration file either in XML, JSON, or a proprietary binary format loads rapidly, requires little code, and is completely reliable. A DBMS overhead would slow down the system, use expensive memory, and offer no visible benefits. In embedded systems, when every kilobyte counts and dependability is critical, simplicity is preferable. Okay, so these are the scenarios in which file processing is better. And now let's talk about performance considerations. So DBMS performance characteristics. So several factors influence performance when using a DBMS for large-scale data retrieval, such as compiling a monthly sales report from millions of transaction records. So first, query optimization comes into play. The DBMS query optimizer evaluates the SQL query and creates an efficient execution plan, which may include indexes to avoid full table sources. If the table fields and product categories are properly indexed, the DBMS can quickly discover relevant records without having to read the full database. Okay, and however, DBMS systems have intrinsic overhead. Every query goes through several levels, including the query parser, optimizer, transaction manager, and buffer manager. While these layers are flexible and safe, they waste CPU cycles. The DBMS optimizer can significantly improve performance for sophisticated queries that link numerous tables with aggregations and sorting when compared to human programming, but basic sequential scans may be slower than direct file reading due to the overhead. Furthermore, DBMS systems keep transaction logs and handle concurrent access even for read-only tasks, which increases overhead. Crucially, DBMS systems employ sophisticated buffer management, which caches frequently requested data pages in memory, allowing subsequent queries to discover data that has already been loaded, significantly improving performance. Okay, so traditional file processing performance. So in traditional file processing, obtaining the same sales data requires custom programming. If data is stored sequentially, the program must read the entire file and examine each entry to see if it meets the criteria. This can be quite fast for pure sequential reading from disks because modern hard drives and SSDs are designed for sequential input-output. So however, if you want data that is not in sequential order, such as all transactions for a given client spread across the file, performance suffers dramatically. Without indexes, you have to scan the entire file. Indexing can be implemented manually, but it is difficult and error prone. Furthermore, if numerous reports require different access patterns, you may need multiple sorted copies of the same data, which wastes storage. Okay. So in comparative analysis, so for truly large scale activities such as retrieving 100 million records, the contrast is interesting. Okay, so if you need all records sequentially, a well optimized file data system that reads directly from disks may outperform a DBMS since it eliminates overhead. But however, this is rarely the case in the real world. In practice, large-scale retrieval typically requires specific criteria, several data sources, and sophisticated aggregations. DBMS wins because indexes query optimization, and efficient join algorithms surpass hand programming. A DBMS can execute queries in parallel, splitting data across numerous processors or drives. Modern DBMS systems can use columnar storage of data to perform analytical queries, reading only the relevant columns rather than the complete record. The DBMS also ensures consistent performance regardless of data access patterns, whereas file-based performance varies dramatically depending on how data is organized or accessed. So the final recommendation is evaluate specific use case requirements before choosing an approach. Okay. So thank you for listening, and I hope you liked it. And if you have any questions, feel free to ask in the comments. And thank you so much for watching.